In this lesson, you will learn how Hadoop uses MapReduce. You will also be able to describe the MapReduce lifecycle. You will learn the role of the job client, the job tracker, and the task tracker, and know the workings of the map tasks and the reduce tasks. Understanding each of these processes and pieces is essential in learning Hadoop. In addition to the HDFS, MapReduce is part of Core Hadoop. Tools such as Pig and Hive are built on the MapReduce engine, so to learn these tools, it is important to first learn MapReduce. MapReduce jobs are written in Java. Developers with Java skills will pick up MapReduce faster than developers who are versed in other languages. The job client is a Java class that submits a MapReduce job. Depending on how it's used, the class is usually instantiated in the main method of a Java program. The job client provides methods to submit MapReduce jobs, track their progress, interact with other MapReduce tasks, and get the Hadoop MapReduce cluster information. The steps in MapReduce job submission involve validating both input and output specifications of the MapReduce job, computing the input splits for the MapReduce job, if needed, initializing the required accounting information for the distributed cache of the MapReduce job, on the HDFS copying the MapReduce job's jar and related configuration, and finally, submitting the MapReduce job and monitoring its status to the job tracker. The job tracker is a Hadoop MapReduce service that assigns MapReduce tasks to data nodes on the Hadoop cluster. It is initiated by the job client. The job tracker runs on the name node and contains the algorithm that determines which data node receives which processing portion of the MapReduce job. The job tracker communicates with the task tracker on each of the data nodes. Each of the respective task trackers notify the job tracker of the health or death of the data node, so the job tracker may assign MapReduce tasks. Another feature of the job tracker is it attempts to move MapReduce tasks to where the data lives. This is one of the pillars of Hadoop, to move processing near the data rather than move the data to the processing. Task trackers run on the data nodes and are responsible for communicating with the job tracker. The job tracker is a single point of failure on the Hadoop MapReduce services. If a job tracker fails, all running MapReduce jobs fail. The task tracker monitors MapReduce processing within its own node. Task trackers are not aware of other data nodes and their respective task trackers. Remember, data nodes only communicate with the name node, and data nodes never communicate with each other. Let's go over the map phase, or the mapping lifecycle. 1. Inputs from the HDFS are fetched into the local copy according to the required input format. 2. Key value pairs are created. 3. The specific job according to the map function will be applied to all the key pairs. 4. The data will be sorted, aggregated, and combined locally. 5. The results will be saved in the local file system. 6. Once the task is done, the task tracker will be informed. 7. The task tracker informs the job tracker. And 8. The results will be passed on to the reduce phase by the job tracker. Now let's go over the reduce phase, or the reducing lifecycle. The user may stop the job after the map phase, making the reduce phase optional. There are 3 main steps in the reduce phase. They're copy, sort, and merge. 1. A reduce phase task initially fetches the job functions from the local file system. 2. All the copies of the map phase results from the tracker will be fetched and copied. 3. The copied results will be sorted based on the key value pairs. 4. A single set of key value pairs will be created and merged with the original sorted values. 5. The reduce function will be applied on the consolidated list of key value pairs. And 6. The final results will eventually be smaller than the input data and stored in the HDFS file system.